So TJ mentioned in Toronto last fall, we did a session and it was part of a panel, and we're trying to infuse some knowledge of how things work there. And TJ said his inner geek really started to kick in, and all the stuff of how do spam filters really work just were super interesting to him. During the panel, we hinted at a few things. I got a bunch of questions after, and it seemed to be interesting. So we decided it'd be good to kind of do an independent, how does spam filtering stuff really work? Before we get into it, a quick question. How many people in this room think they know how spam filters work? It's a mystery, yeah. Or how do maybe a better question is, how many people have received a spam and look at it and are like, why the hell did the spam filter not stop this thing? Yeah, probably a lot more hands with that one. I've been in the spam industry for about 20 years, either working directly for spam vendors or working with spam vendors. So keeping this pretty generic, I've worked with lots of different companies. I kind of understand what makes things tick. And rather than going deep into Proofpoint technology, and kind of give it just a generic perspective of what do all spam vendors have in common? How do we tackle the problem? How do we, what are the building blocks that help us make that determination? And of course, there's perils in this stuff. It's an imperfect science. So you can start to understand and appreciate some of the complexities and how we detect this thing, but also some of the complexities and how errors and things can be made as well. There's been a lot of talk about AI in all the sessions, so I got to talk about AI just like everyone else. So here's my talk about AI. See that headshot? That was AI generated. About a year ago, I realized my headshot was really out of date, so I did one of those online AI headshot things. You just take a bunch of selfies. And that one came out pretty good. There was some that had me with goatees, some that had a beard, so AI's not perfect either. I had a mullet in one of them, tattoos and stuff, so yeah, AI is not going to solve the world overnight, but really useful technology and generated that headshot, which is pretty cool. Without further ado, let's kind of go into it a little bit and start digging into the technology and the ecosystem and the players. Whoops. Actually, before we dig into, sorry, this thing is way out of sync. Before we dig into the technology, I did want to talk about the ecosystem and the applicability of this stuff. This is my uber simpler diagram that I present to executive management of how does mobile work, right, and how to simplify it. And before people throw rotten eggs at me, I know it's a lot more complex than that. But there's different players in here. Each one has a role in security, and some of the stuff I'm going to talk about, all of it can be applied in different ways. In different aspects of the network. So whether you're an MNO trying to protect your subscribers, and you have an interest in protecting subscribers, protecting your revenue, ensuring compliance, right? You've got a certain interest in some technology to help you do that. You might be an aggregator. You're trying to perform similar things as well, make sure all the messages delivered. You're not paying for things that don't get delivered, so there's interest in the technology, but from a different perspective at an aggregator level. And similarly, if you're a mobile content provider, you're in the business of carrying these messages, ensuring revenue. You got to make sure you get high deliverability, and your messages, the wanted messages, are getting to the people that want them, and unwanted messages or actors that are creating problems in your network, those are getting removed so that you can maintain that high deliverability. So all this technology that I'm going to talk about, and again, I'm trying to do my best to talk about it very generically. Can be applied to extract different information depending on where you sit in the network. So a little bit about how we think about how we have to tackle the spam problem and design new techniques and design new algorithms, as well as how realistically any vendor, including the multiple vendors that I've worked with, design their algorithms. This kind of goes into the fundamentals of what problem are you trying to solve, and what actors are you up against that you're trying to solve this against. This is one of my favorite examples that sort of helps to enlighten people of the kind of things that we're up against. And what this is this is data from a trial we did, I don't know, a year or two ago. I forget exactly when it was. What's over on the left is 3 separate spam or phishing campaigns that we started seeing when we first installed some systems inside this mobile network operator. And it was only 3. It's pretty simple, right? You know, one phishing attack looked like this. Maybe it had changing URLs, but you could tell it was all one attack. There was another one that was some other type of scam, and a third one that much lower volume. So pretty simple stuff. Only 3 attacks going on at any given time. But remember, we're in a trial, so our systems weren't activated, right? They're just logging messages, doing nothing, and we were celebrating. Fantastic. Pop this thing in. Within hours, 3 phishing attacks bubbled to the top, getting great confidence that this stuff's easy and the system's going to be pretty effective. So the customer got pretty excited. They're like, that's great. You know, we need to stop those 3 attacks. Switch from logging mode to blocking mode right now. What do you think happened when we did that? 3 turned into 3 dozen, 300, 3,000 almost immediately. This wasn't like in a matter of, took them a couple of days. They realized, oh shit, I'm getting blocked. I'll have to go retool my scripts and do that. It was within minutes and hours, right? That's how reactive these guys are, right? Their tooling is ready to go faster than you can think of, putting a new rule in place, right? So back to the philosophies of how you have to design a system, they have to be, near real time and data driven. These guys have a lot of sophistication that they built through the years to morph it, detect when they've been detected, figure out ways around the system. And these guys are professionals. We joke about professionals. They're threat actors. We don't like to talk them about that way. But this is their job. They have 8 hours a day. They have more time in their day than I do to sit there and figure out how to get around the filters. And they've automated that using techniques, AI, you name it. So in thinking about the building blocks of how spam filters have to work, we've got to think about what the sophistication and the motivations are on the other side. So this goes into the thought process behind every step we take. It goes into the thought process of how quickly we need to have systems that can react to it, because we know the guy on the other side is already a leg up with the sophistication on their side. So let's talk about some of the building blocks. And again, this is, I tried to design this to be very generic. And there's elements of all these building blocks in every vendor, including Proofpoint, that I've worked with. They all may be implemented in slightly different ways or different level of maturity, but each one has to kind of tackle these problems, build an automated system, and design these things so they could rapidly iterate. And the goal is to make sure that you can keep up with a threat actor that has the ability to react that fast when you put a defense in front of them, right? So these are the building blocks used in different ways by different vendors, but are fundamental to the way we try to attack this problem. So I'll go into each of these a little bit briefly right now, but I'll give some examples of it in a bit to add a little bit more color to it. But I kind of want to paint the picture of all the different building blocks and the kind of things that we have to use to tackle this problem. So first building block we call normalization. So spammers are smart, and they will do everything possible to insert noise into a message. You guys have all probably received messages with like weird punctuation and dashes and dots, right? No 2 messages are alike. That's been the case for like 20-some years, all the way back to the email spam days. The original spam filters were based on an MD5 hash. Yeah, that worked for about 10 minutes, right? They're sticking inserted random noise in there and trying to fake out the systems. So first step into this is normalization, right? And that's the kind of, think of that as like a noise reduction phase. We have to get rid of the garbage. That's just a distraction from that. Maybe get down to remove punctuation, get all the garbage out of there, get into something that we can actually start to analyze that start to make sense. Next step, message clustering or attack clustering or grouping. Goes by a bunch of different names, but when you think about what we're trying to do, we're trying to figure out and make a determination, should we block something or let this something go through? Is this something good or is this something bad? That's an easy statement. It's really hard to do because what is something? No two messages are alike. So if I'm making a determination on this message and I have to recalculate and make it again on a second message, I'm never going to win, right? So this grouping goes by different names, clustering, fingerprinting, whatever you want to call it, is this concept of figuring out what do I want to make a determination, what do I want to start attaching statistics to, tracking behavior, and then applying my algorithms to make that final determination. If I do it right, I can make a determination on this spam campaign. It doesn't matter if it's got 100 URLs, it's coming from 5,000 different phone numbers. It's one thing. I make a decision on that one thing, and now I can propagate that and block all future variants of that thing. In the spam world, we call that getting precision on an attack. And it is a bit of a game, right? We're trying to encompass as many variants of a spam campaign using one identifier, a fingerprint, an ID, whatever you want to call it, without having that accidental problem of, oops, I made that net a little bit too wide and I picked up some of those legitimate messages by overgrouping and creating some false positives. So we call that precision. So once you have that set, we now understand this is a phishing, this is a campaign. It's something. I don't know if it's legitimate or not. Now I have to start tracking statistics about that. Behavioral analysis, feature extraction, a whole bunch of different names. This is the art of now tracking statistics about that thing. How many spam complaints are there? What are the characteristics of it? Now I can take that thing and start using the data to make a decision and collect data about it to make a decision to see, is this thing good, something that people really want, or is this thing something bad that maybe is unwanted in the network? Another key aspect that every vendor implements in one way or another is the concept of sender reputation. Sender we'll use very generically. That could be a phone number, it could be a global title, it could be a TCR registered campaign ID, all different concepts of sender. But really important because you're trying to make this determination about this thing that we've identified, a group of messages going through the network, but understanding the reputation of where it's coming from is a huge influencer in how the systems need to work to make that final determination of is this bad or is this legitimate? So everything I've talked about up till now is all about grouping, identifying, and collecting data. Now is where the real fun kicks in. Machine learning, right? I mentioned this in Toronto. I'll mention it again. Anyone who thinks they understand how spam filters work probably has it wrong, right? Mentally, people think that spam filters must be rules-based, right? You spelled the word bank wrong, you got some weird stuff there. That's how the spam filter works. And that's natural. As a human, you look at something and we have our own processing algorithms in our head. We can make that determination that this is a threat or not. That's not the way machines work, right? Especially machines that have to process billions of messages a day. They're using very different algorithms to process this. Every spam filter in the world uses some form of machine learning algorithm. We are basically big data engines. We're processing data, we're making determination, we're taking all that data that we've collected, there's behavioral statistics, and we're running machine learning models against that to be able to get real-time decisions on these things. So that's where machine learning kicks in once we've detected that, once we've collected enough information on that. The next piece that tends to get talked over whenever people talk about machine learning and AI and all the good stuff is automated retraining. Everybody loves to talk about machine learning, right? And that's the concept of training a machine based on some data to be able to make a decision for you. Anyone know ChatGPT? Really cool. It's amazing. It can solve all kinds of problems for you. Does anyone know the last time ChatGPT 4 was trained? April. January 2022. There might be some incremental stuff, but according to their website, January 2022. So imagine a spam filter that was last retained in January 2022. It's not going to be very effective, right? ChatGPT, based on its training model, is great for certain problems. You ask it a question about something happened before January 2022, it's amazing. Ask it a question that happened more recently, it may fail. Automated retraining is key, right? I mentioned before, spam filtering engines are basically big data pipelines. We're processing data. We have to process that in an automated fashion. We can't rely on retraining this thing once a year, once a month, right? These things need constant real-time data because the guys who are working against us are constantly changing their techniques, and we need to constantly keep the systems up to date with those techniques. Human-assisted retraining, nobody likes to talk about this one either because nobody likes to talk about humans. We're a technology company. Look, humans are a part of this. Every spam vendor runs a security operations center. Does that mean they're sitting there whack-a-mole, pushing a button and blocking stuff? I certainly hope not. But there is a role, right? Humans are smart. They can make decisions that sometimes that computers can't make for us. Not the most scalable thing in the world. And that's where AI, I think, has, Mr. Loudon talked about this in his earlier presentation. There's a great applicability of AI is to take some of those manual roles, help do human-assisted retraining and bring things up to, bring knowledge up to the top, where we can figure out, the spam filters are working great, but maybe I need a new machine learning model to be able to assist the computer. And AI can help analyze that data for us and bring those things to light. So those are all the key elements. I'm going to jump into a couple of these in a little bit, just to give a few examples. Probably would have been more interesting if I'd done this all along the way. I don't read Russian, but this is a Cyrillic-based message. It's actually a legitimate message. If you look at the ones on the left, they look completely identical. But if you happen to calculate an MD5 on those, different MD5 for every single message. Well, how could that be? Well, sure enough, they're using Unicode lookalike characters. Common technique to do substitute lookalike characters. Simplest stuff. They look identical, but they're designed to flip the characters to avoid spam filters. In this case, this is actually a legitimate message. It's a Russian 70% off coupon or something like that. So in this case, they're trying to avoid gray traffic detection by inserting, altering letters in there to avoid detection. There's this really cool website. Actually, the link to it's down the bottom here. You guys get a copy of this presentation after. I was going to do a live demo, but I did the next best thing, which is an animated thing. Unicode Consortium publishes something called the Unicode Confusables. Fun little demo. You get to type in anything you want. It tells you all the different ways you can spell something. So type in the word MEF Miami. Thought that'd be kind of fun to do. And there you go. There's all the different ways you can make something that kind of looks like MEF Miami, but it might be good enough to invoke someone to click on a message, but is actually a completely different form of it. Anyone want to take a guess how many ways you can spell MEF Miami using lookalike characters? 10,000, 100,000, million, billion? Ready? Whoops. Not going. 1.3 trillion, 1.38 trillion ways to spell MEF Miami. That doesn't even include Unicode invisible characters, like formatting characters. That actually excludes a ton. So 1.3 trillion ways to do that. So why is normalization important? If they're going to flip these characters on us, we have to get down to a normalized form if we're going to be able to track this stuff. So a good example, maybe we want to track the word Citibank in all of our messages. They're going to spell Citibank 1.3 trillion different ways using lookalike characters. We've got to get down to normalization to realize, aha, this is something trying to reference Citibank. Content clustering or attack grouping. Back to this concept. I'm trying to program a machine using machine learning algorithms to make a decision on something. This is all one spam campaign. As a human, we can look at that. It's all the same thing. Teaching a computer to do that is pretty hard, right? They're personalizing it with first names. The words jumble. The 2 to quit, 7 to end, 7 to unsub. The stop message is completely different. completely randomized. If you did an MD5 hash on these, different one for everything. But as a human, we can look at that and we realize that's all one campaign. So another key attribute to figuring out, is this one thing that I can block or a dozen different things that I have to make a determination on independently? I'd much rather calculate statistics and behaviors on one thing, not 12 different things or 12,000 different things. Another part of normalization is clustering that and realizing it's one thing that we can now start collecting statistics on. Another example of normalization, these are legitimate messages, right? So ADP messages, if you're trying to detect gray traffic in a network, ADP messages, no two ADP messages are alike. The flight number changes, the time changes, the personalization, your account ID may change. So how are you supposed to detect this gray traffic in your network? Again, content clustering and normalization can remove the variable parts and realize this is one thing. Now I can trace it in the network, identify gray traffic, and decide what I want to do with that kind of gray traffic. Behavioral analysis and attribute tracking. So once you've figured out, I got something, it's interesting, I need to start tracking some statistics about it, that's where the attribute and statistics tracking works. The example I threw up here, if anyone recognizes this is from the CTIA Best Practices Guide. I think it's the 2019 version. The CTIA, this is a really simple list of attributes, but really interesting list of attributes. This is an example of behavioral tracking. The application of it was very simple, but their goal was to come up with a very simple definition of if you're going to track behavior about a phone number, how do you know what's acceptable for human behavior versus automated behavior? They come up with just a couple simple rules. Some are super simple, throughput, volume, but then it starts to get a little bit interesting. Balance, are we doing one-to-one messaging? Repetition, is it the same message over and over? A bunch of simple characteristics to help determine, is a phone number potentially a human, or could it be an automated sending application? What's interesting about this, and I love these CTA guidelines, due to their simplicity, but where it's lacking is the fact that there's no sort of automated learning behind that. If you look at these limits, they're kind of hard-coded. You had to put something down on paper. Nobody's allowed, a human typically doesn't send more than 1,000 messages a day. A human typically doesn't send to more than 100 people a day. That's reasonable. What do you think the fraud guys do? Well, they send 99 people a day. They send 999 messages a day, right? They're pretty clever. So great example of tracking characteristics based on something simple, like a phone number, but because it used a fixed set of rules to define the good versus the bad, sure enough, you're going to have the threat actors immediately working around that. So a good example, but a really, really simple one. So behavioral analysis goes well beyond that, right? That example was really simple. Let's take a phone number and track some simple volumetric characteristics about that. Behavioral analysis goes way beyond that, right? We're not just tracking information about a phone number. I might be tracking information about a group of similar messages. And what kind of information am I tracking? It's not as simple as a volume or a one-to-one ratio characteristics. We can track over time the frequency that they send URLs. What kind of URLs are they sending? Are they modifying the messages and changing the URL every certain amount of time? All that set of characteristics can be fed into a machine learning model and make a much more intelligent decision than a simple rule that says if you send more than 1,000 messages a day, you must be an ADP message, right? So this is key. We're tracking information about things. That information can vary. It gets much, much deeper than simple volumetrics, but then we can then start applying the machine learning algorithms to that to make much more intelligent decisions based on the history and definition of the attributes that we've collected. So how do these pieces come together? I kind of hinted that a little bit when I talked about the ensemble slide. By the way, ensemble is just another word for bringing multiple bits of technology together. There's other definitions of it as well, whether you call it security in depth, layered filtering technology, layered technology. But the key is nobody is just doing one thing, right? We're taking multiple steps, these building blocks, trying to apply automated algorithms to them to make real-time decisions about not individual messages, not necessarily individual senders, but things as a whole, so we can keep up with the type of threat actors that are trying to constantly work around these. So I talked about all the things up top, but I haven't really talked much about the concept of continuous retraining. As I mentioned before, spam filter vendors are really nothing but big data engines. We are constantly processing data, whether it's data pulled out of the messaging stream, data pulled out of 7726 reports. We're processing that. That is training data, right? That's how machine learning algorithms work. They're adapting to data that they receive and improving and influencing the decisions they make on these things. What kind of data can you use to do that? 7726 and spam report data is fantastic retraining data. It's not perfect, right? It's imperfect. I had a couple people ask me during lunchtime, how the heck do you process that kind of data? It takes a lot of technology to take a very imperfect signal like that and figure out, can you use that for retraining data? But when you think about it, it's powerful. It's near real time. You have 200-some million people across the US clicking a button, giving you some sort of opinion to help retrain a system. That's way more effective than once a month I put a bunch of analysts in a room and have them manually classify messages and retrain the machine learning models. Using that data is difficult. It takes a lot of data science to make that happen. But having the ability to have that signal come in real time and continuously improving those models is key. Because remember, that threat actor is constantly finding ways to get around that. So this idea of constantly retraining is key. There's other sources of data that can be used into that sort of continuous loop. Operator-assisted retraining, again, back to the human aspect of it. Nobody likes to talk about it, but having humans actually influence the system, find those things that are maybe getting through the system, influencing those machine learning models is key. We run a security operations center, and they're looking at content, looking at things that are potentially missed, but the thing that they're not doing is trying to make one-to-one decisions. What they're really doing is feeding data into the system, so it's that much better to be able to block those the next time something similar comes around, and retraining the system to be that much more effective at blocking things. Honeypot and spam trap data hasn't been widely used in mobile. There have been some experiments to try to use that. It's another source of training data to feed into the system. If we hit spam traps, unused phone numbers, unroutable number space, that's a signal. It's not a perfect signal, but it's a great signal to feed into these machine learning models. But whatever that data source is, the key is we can't think about this in terms of once a month I'm going to try to retrain my machine learning model. This needs to be a continuous data processing pipeline. That is the only way you're going to keep up with the kind of things that are being attacked against the system. There we go. This was super high level. I tried to keep it not specific to Proofpoint, and if anyone wants to go build go start a spam filtering company, arguably these are the kind of building blocks you got to go hire people that know how to do. But I thought I'd end it with a kind of a great quote from the great one, Wayne Gretzky, and apologize for the non-Wayne Gretzky fans in the room or people from other regions. But his famous quote was, "Skate not to where the puck is going," or skate to where the puck is going, not to where the puck has been. And that's kind of what we have to think about in the spam filtering world. It's so easy to post-process analyze data and realize, great, I need to build a new algorithm that blocks that thing that came in yesterday. That's only going to help you with the stuff that's yesterday. The other guy's a step ahead of you. You have to design systems that are ready for where that puck is going and are ready to react when the puck changes direction. So, thank you. See you.
We have time for a few questions. One time to get a mic over to you guys. Questions?
Thank you. So I was thinking in terms of, I mean, you're going to be, I'm just thinking about a network deployment. You're going to be sitting in front of the SMSC, which is ultimately going to be delivering those messages. So your call to action, I guess it depends upon each operator, but are you blocking? Are you sending it off to a special place to do further analysis? What are all the things that are possible from your platform?
It depends on the deployment, but yeah, ultimately you're trying to make a determination on something, which is going to influence what happens to a message. The implementation will dictate what happens beyond that. Does it go off to a quarantine, get logged, and what data will get captured?
How important are read receipts? How important are read receipts to the bad actors? Do they care? Because they'd much rather get somebody to click a link, and that's a bigger signal back to them than a read receipt for an SMS delivery.
It's less important. Well, I guess it depends on the type of attack. So if anyone remembers the early days of email, we all got trained to don't click on those links. You're letting the spammer know. Honestly, they've automated their systems to the point where they don't necessarily use that data, right? They're going for the spray and pray type approach. The more sophisticated attacks that use social engineering don't even necessarily need read receipts because they're waiting for a reply where they're trying to engage in a social engineering conversation. So read receipts aren't critical for the spammer to necessarily know that, I've got a bait and hook behind that. Any other question?
Well, Mike, thank you for
Thank
making
you.
the nerd in me happy. I really enjoyed it.